All right, so yesterday we were practicing our skills to do with chemical reactions when they are written in this form. Okay, so we learned we practiced the different types, okay, the 5 types, synthesis reactions like number 1, okay, decomposition reactions like number 1, synthesis reactions like number 4, okay, single replacement reactions like number 2, double replacement reactions like number 5, and combustion reactions like number 3. Okay, so we're going over the types, we're learning those, we're getting the hang of how to identify the patterns, okay, and we're practicing writing them out in words, and then balancing the formula reaction. Okay, that is the easier of the 2 ways for reactions because all the numbers are already done for you. Okay, when you see these formulas, you know somebody's dropped and swapped them, you know all the numbers are right, and the balancing is easier. Okay, it's not so much harder, but there's more detail that you have to be careful of and aware of when we are doing reactions from word form to formula form. Okay, and that's what we're going to work on today. Here's why you have to be more, let's say, on the ball or aware when you're doing these. Okay, you have to build all the formulas here. They give you the names. But that means if it's ionic, you've got to drop and swap it. And you've got to drop and swap it correctly. If you don't, you won't get the reaction to balance. Or at least balance correctly. Most of the time it just won't balance. So, as a tip, if you've been working on balancing the reaction you wrote and you just can't get it to balance, chances are you messed something up in one of the compounds and you just have to go back and check that. Okay? But the big thing here is drop and swap correctly, okay, get the formulas for molecular ones correct, but the biggest one is the special elements. Okay, so in a reaction like number 8, for example, okay, it says lithium nitride breaks down into nitrogen and lithium. What do I have to remember about nitrogen when I write it?
It's a molecular element?
Yes, and it comes as a 2 when it's by itself. That is the most common mistake I see when people are writing reactions from word form to formula form is they forget the special elements. So they just write N instead of N2, which means the reaction's wrong and you'll get the balancing wrong too. Okay, so you have to be careful and remember, oh, I've got elements that were formed, I need to go and double check were any of those special, okay, and then put the correct number on. All right, so here's what I would like you guys to do. Let's go over number 8 right now, just because we started talking about that, and then I'll have you do some of the others here. Okay, so for number 8, it says lithium nitride breaks down into nitrogen and lithium. So the first thing I need to do here is write out all the parts of this reaction. Lithium nitride is the first one. Is that ionic or molecular? It's ionic. Lithium's a metal. Okay, so I'll go Li. Okay, and that's a positive 1, okay, and it is with nitrogen, which is a -3. So what do I have to do with those? Drop and swap. All right, so I'll have Li3N for my formula. All right, and it says it breaks down. So is it reacting with anything? It's not. Okay, so I just write the arrow then. Okay, breaks down into nitrogen and lithium. So I'd write nitrogen and I'd write lithium. Okay, at this point I have to go, all right, is there anything I need to check for? I've got 2 elements here. What should I check for? I should check if any of them are special molecular elements. Okay, is lithium a special molecular element? No, it's a metal. Okay, what about nitrogen? It is. Okay, and what does it come as when it's by itself? As a 2. All right, now I've checked those things. Those are the little things I've got to ask myself as I'm doing this. Okay, you're going to get annoyed by me when we're doing these as a class because I am going to say every little thing that I'm thinking as I go through this. And that's what I want you to be thinking in your head as you're doing reactions. There's little checks and balances and things like that that we want to make sure we do every time we write a reaction so we get it right. Okay? When people get them wrong, it's not because they don't understand. It's usually just because they go too fast and they don't check for those little details. Okay? All right. I've got it written out. What kind of reaction is it? It's a decomposition reaction, right? I have one reactant. It's breaking down into two elements. All right, so yes, that is a decomp reaction. Is it balanced? It is not. All right, what should I balance first? Yeah, I can go with the biggest number here, okay? If I do that, though, if I put a 3 here, okay, because that's our rule that works 95% of the time, this is one of the 5% it's not going to work. Because now, I have to balance the nitrogen, which means I got to come back here and put what in front of this? A 2. Okay, does that throw off that number? Okay, so then I just erase it. That happens sometimes. It's not a big deal if it happens. Okay, we followed the rule. We went with the biggest number. It didn't work this time. No big deal. Okay, 2 times 3 is 6. Okay, am I balanced now? Okay, that's all there is to it. It's not a lot different fundamentally than what we were doing yesterday. You just have to make the formulas yourself now. Okay, which just brings in more chances to make a mistake if we're not careful. All right, I would like you guys to try 6, 7, and 9, okay, right now. I'll give you a few minutes, then we'll do number 6. Give you a few more minutes, we'll do number 7. Okay, so we can kind of check them as we go along. All right, so for number 6, we got copper 2 nitrate, ionic or molecular? Ionic, okay, so I'm going to write it like an ionic compound. Cu, what charge am I using for copper this time? 2 plus, that's what the Roman numeral tells me. Okay, and it is with nitrate, NO3, which has a -1 charge. So when I drop and swap, the 1 would go there, okay, and the 2 will go here, and that will require brackets so that I'm saying I have 2 nitrates and not 1 nitrogen and 32 oxygens. All right, so there's the formula for copper 2 nitrate. It is reacting with magnesium, so just Mg. Right, and that is going to form magnesium nitrate, so Mg, right, it's a 2 plus with nitrate, okay, it's a 1 minus, drop and swap, okay, the 1 goes here, the 2 goes here, so it's kind of the same as on the other side, okay, plus copper. Okay, what kind of reaction is that? It's a single replacement reaction. Yeah, we have an element, it's reacting with an ionic compound, and it's replacing part of that ionic compound. The magnesium replaces the copper, and the copper ends up alone. All right, so yes, this is a single replacement reaction. All right, is it balanced? Actually, it is, yeah. Okay. If we look at it, if we count each thing individually, there's 1 copper, there are 2 nitrates, 1 magnesium, 1 magnesium. Okay, we're done with that one. Now, if this was on a quiz, okay, or something like that where it was fill in the blank, okay, so the whole reaction was done, right, for you, and it was just a balancing exercise and it had blanks there, okay, actually put 1s in all the blanks. Otherwise, I don't know whether you knew it was balanced or didn't know how to do it and left it blank. Okay. The other way that this can get tested on a unit exam or a quiz is with a numerical response item. Okay, so you basically get like a table like this, and then you have a bubble sheet. Okay, you would go 1, 1, 1, 1. Okay, a 1 goes in each box because each box corresponds to the blank. Okay, so there's a couple of ways that you would do that on a quiz or a test. Okay. All right, how many people have done 7? All right, I'll give you a couple more minutes on 7. Obviously, we know the first part of it, C12, H26. Okay. All right, so for number 7, okay, we've got C12, H26, that's what, dodecane or something like that, okay? And it's reacting with oxygen gas. What do I need to remember about oxygen gas? It's a special element, right? We always write oxygen as O2. It's the stuff we breathe in. It's also the stuff fire needs to survive. Okay, so O2. And that is going to produce, as all of these reaction types do, carbon dioxide and water. And what reaction type is this? This is a combustion reaction. Okay, special balancing rules. Do I need them both? I do. 12's an even number, so I need to start with the rule of 2. And then I have to balance in alphabetical order. 2 times 12 is 24. So I will need a 24 there. Okay, I'm going to get some really big numbers here. 2 times 26 is 52. 26 times 2 is 52. Okay, we're good there. All right, now I've got to balance my oxygens. It's last. All right, 24 times 2 is 48. All right, plus 26. Oxygens here. 74? Okay. All right. So what's 74? That'd be 37, right? 37 times 2 should be 74. Okay. I wouldn't give you one that big on a test. Okay. I'm not trying to test your multiplication tables. Just seeing if you can balance things. All right, I'll give you a couple more minutes here on number 9. Are there any questions on 7? Okay, give you a few more minutes on 9 here, and then we'll go over that one. Oh, there we go. Okay. All right. So, what does phosphorus look like when it's an element by itself? P4, right? Okay, one of the special elements. And it's reacting with oxygen. Is that also special? Okay. Not as special. Okay, it's only a 2, right? But now, they are going to produce triphosphorus dioxide. Is that ionic or molecular? Molecular, yeah. They're both nonmetals. It's full of prefixes. Okay, always a dead giveaway. So triphosphorus, P3, okay, dioxide, O2. All right, what kind of reaction is that? It's a synthesis reaction, yep. Okay, oxygen's already balanced, but the phosphorus is not. So biggest number is 4. All right, I've got 4 phosphorus in the reactants, only 3 in the products. Lowest common multiple, 12, yeah. Okay, so what do I have to multiply this side by? Okay, this side, 4. Okay, so now I've got 12 phosphorus and 12 phosphorus, but now I also have how many oxygen? 8. Okay, what needs to come over here? Right. Okay, now, if you forgot that phosphorus was special, or oxygen was special, would you get that reaction right? No. Okay, here's what I would say this would be worth. I would give you 1 mark for your reactants. I'd give you 1 mark for your products. Okay? I would give you 1 mark for the reaction type, and I would give you 1 mark for the balancing. So if you don't remember that phosphorus is a special element, you don't get this mark. Okay? You might still get the products right. Okay, so you could be okay there. You might still get that mark, and you'd probably still get the reaction type mark. But would you get the balancing right? You might actually get it to balance, but the balancing wouldn't be right because the reaction itself wouldn't be right. So the best you could hope for on a 4-mark question there would be 2. Okay, so it's really important to remember those special elements. That is, without a doubt, the single most common mistake I see in reactions. People get the swap and drops wrong occasionally, but most of the time they get that right. People get the prefixes right. Okay, it's forgetting special elements that happens most often. Okay. All right, how are we feeling about going that way? Okay. It's a bit more to do. Okay. Where we're headed to is this. I give you just the reactants in words, and you have to predict the products and balance the reaction. Okay? I know, right now that probably sounds really intimidating, but actually it's not that much harder than what you're doing right now. All of the reactants all of the reaction types start differently, don't they? Right? Like a synthesis reaction is always 2 elements reacting. A decomposition reaction is always just 1 compound. A combustion reaction is always a hydrocarbon and oxygen. Okay? Double replacement is 2 ionic compounds. Right? Single replacement is an element in an ionic compound. You can tell what reaction type you're dealing with just from the reactants. And then from there, you just use the pattern to put the products together. And it's really not that hard once you're familiar with the reaction types and the patterns, which is why we're still going to be working on this kind for a little while, so we get familiar with the patterns. Okay, but it's why it seems redundant, but I'm always talking about here's the pattern, that's why. Okay, I want you guys to really learn the patterns. Okay, in your workbook, you will find this sheet. Okay, so it's a lot like what we were doing yesterday. And just so you know, if you're wanting to do some of these at home, okay, the keys for all of the worksheets in the workbook are in Google Classroom. So if you go in here, okay, and you go to classwork, and you go to other items here, key for all the naming worksheets, reaction worksheets with keys, okay, so if you went in there, okay, it would bring up a PDF, and that's the one we're about to work on right now. There's all the answers, so you can check your work as you go. Okay? Everybody with me there? We're going to go through those together in class today, to give you some time to try them, then we'll go through them. But if you wanted to work on some more at home, you can check your answers against the key. Okay? It's not coming in for marks, so that's why it's there. Alrighty? So what I would like you to do right now is work on, let's say, 1 through 5 here. All right, so for these, it's reaction type, write it in words, balance it. Okay, just like what we did yesterday. Then I'll put 5 up that are like what we did this morning. It's in words, you put it in formulas, type, balance. All right, so in our first reaction here, we have iron, and it's reacting with hydrogen chloride, ionic compound, because hydrogen's listed first. Okay, and that is going to make iron 2 chloride plus hydrogen. Okay, kind of check yours against that. I do have to put in that Roman numeral for the iron chloride there because it could be iron 2 or iron 3, and I do have to indicate. What kind of reaction is that? Single replacement, right? We've just got one element reacting with an ionic compound. All right, so single replacement. And it is not balanced. Biggest number is 2. All right, I'll start with chlorine just because it's first. I got 2 chlorines on this side, so what do I need to put here? A 2. Does that fix my hydrogens as well? Is the reaction balanced now? It is. Okay, that was all there was to that. Questions on the first one? Are we okay to go over the second one? All right, so on the second one here, we've got sodium, and it's reacting with chlorine, and that is going to produce sodium chloride. Okay, what kind of reaction is that? Synthesis. It's only the 3rd time we've seen this exact same reaction, right? I've used it as an example twice. Okay, so this is a synthesis reaction, and it's not balanced. Biggest number is 2, so what goes in front of the sodium chloride? 2. And when I do that, though, it also gives me 2 sodium, so what has to go here? 2. Right. Okay, this starting to make sense? Okay. It just takes a little practice, right? The more of these you do, the better you get out and the faster they go. All right, how many people have done 3? So on, what's this stuff? Water. Okay. And you can, this is the one thing you can use the common name for. Okay, water breaks down into hydrogen and oxygen. All right, it is not currently balanced. Biggest number is 2. Hydrogen's already balanced at 2, but oxygen is not. Okay, there are 2 oxygens over here, but only how many here? Okay, so what needs to go in front of this? 2. Right, and what needs to go in front of the hydrogen? 2. Okay. Can we go over number 4? All right, on number 4, we have calcium plus oxygen makes calcium oxide. Okay, no Roman numerals required there. Calcium only has one possible charge. What kind of reaction is that? Synthesis reaction. Yeah. Oh, sorry, I forgot to ask, what kind was number 3? Decom. Yeah. Okay, now I gotta balance this thing. Only thing that's out of balance is oxygen. It's also the biggest number, so what needs to go in front of calcium oxide? Okay, when I do that, I get 2 calciums, so 2 there to balance. Okay, anybody want more time on 5? Yes? Okay, give you another minute or 2 here on 5. So on number 5, I've got aluminum. It's reacting with oxygen. And that is going to produce an ionic compound, aluminum oxide. Okay, no Roman numerals or prefixes or anything for that one. What kind of reaction is it? Synthesis. There seem to be a lot of those on this batch. Okay, and it's definitely not balanced. Okay, biggest number is 3 on oxygen. Oxygen's a 3 in the product, 2 in the reactants. Lowest common multiple, 6. All right, so a 3 here and a 2 there balances my oxygens, but it gives me how many aluminum? 4. 2 times 2 is 4, so what goes here? A 4, yeah. Okay, everybody okay with that one? All right, I would like you guys to try now the ones that go the other way. Okay, try those 5. Okay, so these ones are in words. I want the same thing. I want them balanced. I want the type, but now obviously you have to write the reaction out in formula form. All right, so looking at the first one here, we've got magnesium. Okay, so just the element, Mg, and it's reacting with chlorine. How do I write chlorine when it's by itself? With a 2, right? It's one of the special elements. Okay, and that is going to produce magnesium chloride. Okay, Mg, 2 plus, chlorine, 1 minus, drop and swap, MgCl2. All right, so that's what it should look like. What kind of reaction is that? It's a synthesis reaction. Okay, and is it already balanced? It is if you write it this way. Okay, if you don't write it this way, then you have to go ahead and put in other numbers, which are unfortunately wrong. Okay, so you do have to remember chlorine is a special element in order to get that one right. All right, give you a few more minutes and then I'll do the next one. Okay guys, let's have a look at number 2 here. So dihydrogen monoxide is the technical way of saying this stuff. Okay, water, right? And it gives off hydrogen and oxygen. So arrow, hydrogen, special element, oxygen, special element. Okay, important to know those ones. And then we just have to tell me the type. It's a decomposition reaction. And we got to balance it. Hydrogen's already balanced, oxygen is not. There's a 2 over here, so I'm going to need to put a 2 there. When I do that, that gives me 4 hydrogens. Now there's 4 hydrogens on both sides. Now the reaction is balanced. Okay. Anybody want more time on number 3? Okay, let's have a look at number 3. All right, so aluminum and oxygen. How do I have to write oxygen here? With a 2, right? Okay, produce aluminum oxide. So Al, that's a metal, so I'm going to write its charge, 3 plus. Oxygen, non-metal, going to write its charge, minus 2. And then I'm going to drop and swap. So I will have Al2O3. What kind of reaction is that? It's a synthesis reaction, yep. All right, and then I got to balance it. Biggest number is 3, okay? Lowest common multiple of 2 and 3? 6, okay? So a 3 and a 2, and that gives me how many aluminum? 4. Notice anything? We did these 2 in the other one when you went the other way. You could have just gone back and checked your answers by checking them when you went from formula to word. Okay, all right. Give you a few more minutes there on 4 and 5, and then I'll give you a little break. And after we do 4 and 5. So for number 4, phosphorus. How do I write phosphorus when it's by itself? Like P4, okay? And oxygen is O2, all right? And that is going to produce phosphorus pentaoxide. So we're looking at a molecular compound here There's no prefix in front of phosphorus, so how many are there? Just one. Okay, so we're going to have PO5. Penta means 5. So that's our product there. All right, what kind of reaction is that? It's another synthesis reaction. There's a lot of those in the beginning because they're a little easier. Okay, now I've got to balance this thing. Biggest number is 5. Okay, I got 5 oxygens in the products, but I only have 2 in the reactants. What's the lowest common multiple for those two numbers? 10. Okay, so I'm going to put a 2 here. That'll end up multiplying my oxygens there. Okay, but I already see a problem. What is my problem? Phosphorus is a 4. This doesn't balance my phosphorus, does it? Okay, so once in a while that happens. If I see that happening or I get to the end and I can't make it balance, I just erase those numbers and I start over again. Okay, it didn't work when I started with oxygen. So be it. I'll start with phosphorus instead. There's only 2 choices for what to start with here. Okay, I got 4 over here, so I'm going to put a 4 there. Okay, now my phosphorus are balanced. Now how many oxygen do I have? 20. So what needs to go in front of this? Okay, and now it's balanced. That happens sometimes. Okay, don't get frustrated. Okay, if the first time you balance a reaction, it doesn't work, that happens sometimes. You just erase it and start with something else and see if that works instead. Okay, it's sometimes just a trial and error thing with certain types of reactions. Can we do number 5? Anybody want more time? Okay. All right, on number 5, we got nitrogen trihydride. So we're looking at a molecular compound there. Okay, 2 non-metals because hydrogen is listed second, and there's prefixes. Okay, so NH3 is nitrogen trihydride, and it is reacting with oxygen. Okay, and that is going to produce nitrogen, okay, and dihydrogen monoxide. This stuff. Okay, what's wrong with what I wrote? Right, I need a 2 where? On the nitrogen, right? Nitrogen is special. Okay, now this one here is tough to classify. Probably a lot of people looked at it and went, it's a replacement reaction, which I would say that's a good thing to go with, except replacement reactions only happen with what kind of compound? Ionic. Is that ionic? It is not. So this one here you actually can't classify. It doesn't fit into the 5 that we've gone over. It is a type of replacement reaction, but it's not one of the 2 types we went over. Okay, so I wouldn't worry about. I wouldn't give you one like that on a test or a quiz. All right, I got to balance this thing. Biggest number is 3 with the hydrogens. So why don't we start there? But it'll probably mess up. Okay, so I've got 3 hydrogens on one side, 2 on the other. Lowest common multiple is 6. Okay, so I'm going to put a 2 here. It starts out nice because that makes my nitrogens balance. Okay, and if I go over here, I'm going to have to put a 3 here. That makes my hydrogens balance, but man, does it ever make a mess of my oxygens. Okay, so here's what I do when I run into this problem. Okay, I call this the odd even problem. I have an even number over here, and I have an odd number over there. The quickest way to turn an odd number into an even number is to double it. Think about it. Double any odd number becomes an even number. That's why we put a 2 in front of our combustion reactions. Okay, so I'm just going to double all the numbers. I'm going to put a 6 here and see what happens. I'm going to erase this 2. Okay. All right, now I've got 6 oxygens on both sides. I put a 3 here. Oxygen's good. Okay, how many hydrogens do I have? 12. What do I need to put here? A 4. Right, 4 times 3 is 12. Okay, that gives me 4 nitrogens. What needs to go here? A 2. Is this reaction balanced now? It is. Okay, that's probably the trickiest balance I've had you do. All right, that one you had to really think on, okay, to kind of work your way through it. And that happens sometimes. Okay, they're not always going to be, oh, I put one number in and now it's balanced. I'm so awesome. Okay, sometimes it's going to be a little trickier than that. All right, I'm going to give you guys about a 3-minute break here, and then I'm going to throw a couple other ones up on the board here for you to try. So for our first one, iodine. Is iodine special? Yes, it is. Yeah, I2. Okay, and it reacts with magnesium. That's Mg, not special, right? And that forms magnesium iodide, not magnesium oxide, as it was originally posted as. Okay, so that's an ionic compound, 2 plus, 1 minus, drop and swap. You got MgI2. Okay, and that's going to give us an already balanced reaction. Okay, because we got 1 magnesium and 2 iodine on the other side, and that is a synthesis reaction. All right, for number 2 here, okay, I got copper 2 nitrate. So I do have an ionic compound, so I do need to drop and swap. The Roman numeral 2 tells me to use the 2 plus charge. It's with nitrate, that's NO3 with a -1 charge. Drop and swap, gonna need brackets with a 2 outside the brackets. Okay, and it is reacting with sodium all by itself, okay, and that is going to produce sodium nitrate, Na+1 with nitrate -1, so that compound's fine that way already, plus copper. Okay, so reaction should look like that. Now we have to balance it because there are 2 nitrates in the reactants, but only 1 here. So I need to put a 2 in front of this. That balances the nitrates, but gives me 2 sodiums, which are now balanced, and the rest of the reaction is good. Okay, how many people have done number 3? Okay, let's hold off on 3. We'll go over that on Monday. Remember, tomorrow, okay, you've got your quiz. It's on naming, properties, solubility, and polar nature of water. Okay, so lessons 4 and 7 and all the naming stuff before that. Okay, there's no reactions on there, so you don't need to worry about this stuff being on there. You will get your labs returned to you through Google Classroom later today. My hope is we'll be done the quiz in enough time tomorrow to go over the labs tomorrow in class. Okay, thank you to everybody for turning them in on time this morning. Okay, it's actually, believe it or not, quite rare to have all things turned in together at the same time. Okay, so that was good. Thanks, guys. All right, good job today, and we will see you tomorrow.